Hi there, this is the Science Lady doing grade 11 and 12 chemistry. The topic today is the complete summary of the chlor-alkali process. Subscription to the Science Lady channel is free, so subscribe and click notification. Please note that the exam guidelines in caps are followed. The complete summary on the chlor-alkali process can be done on a double folio paper. So get your paper ready. The chlor-alkali process is an industrial process for the electrolysis of concentrated sodium chloride solutions. It is the technology used to produce chlorine gas and sodium hydroxide, or caustic soda, which are commodity chemicals required by industry. So therefore, the chlorine gas, sodium hydroxide and hydrogen gas produced in this process are widely used in the chemical industry. Please also follow this very simple diagram below. Let's have a look at how this chlor-alkali process works. I've already mentioned that it is an electrolytic process. So, electrical energy is converted to chemical energy. So please note that the electrodes that are connected to a battery, and we are using inert electrodes, for example graphite, platinum or nickel. The electrode connected to the positive of the battery becomes the anode, where oxidation will take place, and the electrode connected to the negative will be the cathode, where reduction takes place. Also note that the container is divided into two compartments, and that the compartments are separated by something that is called a membrane. This membrane is selectively permeable, and it will only allow the spectator cations, the Na positive ions, to travel through. Please note that there are 2 inlets and 4 outlets. Brine, that is a highly concentrated salt water, NaCl, and water, H2O, is let in, and chlorine gas, hydrogen gas and sodium hydroxide is let out. There is also another outlet for the unused or excess brine water, and recycling can therefore happen. So let us now follow the process. Brine water is pumped into one compartment and H2O into another. The battery is connected and the electrodes are charged. The brine water compartment, the following happens. The NaCl, or the salt solution, splits into sodium ions, Na positive ions, which we can also call cations, and chloride ions, Cl negative ions. The chloride ions are negatively charged and are attracted by the positive anode, and chlorine gas forms that is then let out or collected. The sodium ions or cations, which is positive, will go through the membrane to the other compartment. At the other compartment, the water is let in, and the water is immediately reduced to H positive ions and hydroxide ions. The positive H ions are attracted by the negative electrode, and the positive H ions then is reduced to H2 gas, hydrogen gas, that is then let out or collected. The positive sodium ions that come from the other side of the membrane now combines with the negative hydroxide ions to form sodium hydroxide, and sodium hydroxide is let out. So there you are, 3 products, chlorine gas, hydrogen gas and sodium hydroxide, were all produced from one substance, namely concentrated sodium chloride, which we then call brine. There are two functions of the membrane that is used. Number one, to allow current to flow via ion exchange, and number two, to maintain neutrality in the compartments. We can mention 4 advantages of the membrane cell process. Number one, there are no environmental risks involved. Number two, it is the most energy efficient system compared to others. Number three, it has economic and environmental advantages over other cells. And number four, it has lower capital and other costs. There are 2 reasons to use inert electrodes. Number one, the electrodes will not react with chemicals, and number two, the electrodes can be reused. The balanced equations for this electrolytic process is as follows. At the anode, you will find oxidation, where 2 chloride ions produces chlorine gas, Cl2, plus 2 electrons. At the cathode, reduction happens, where 2 water molecules receives the 2 electrons and forms hydrogen gas and 2 hydroxide ions. The net reaction, therefore, will be 2 NaCl in a watery solution plus 2 H2O, arrow 2 NaOH in a watery solution plus H2 gas plus Cl2 gas. Please know this balanced equations well. You must also know the characteristics of the 3 products, chlorine gas, sodium hydroxide and hydrogen gas, that is produced. Chlorine gas is a poisonous yellow-green gas. Sodium hydroxide is a white alkaline solid and it is very corrosive. And hydrogen gas is a colorless, flammable and also explosive gas. The uses of chlorine gas, Cl2, to kill bacteria in drinking water, so it acts as a disinfectant, to clean swimming pools, to make hydrochloric acid, HCl, aqueous. Chlorine gas is used as a disinfectant, as a bleach, also to produce the plastic known as PVC, polyvinyl chloride. Chlorine gas as a solvent in dry cleaning products, and chlorine gas is also used in the production of weed killers, pesticides, etc. The uses of sodium hydroxide, NaOH, in the manufacture of detergent, in the manufacture of paper, in the manufacture of ceramics. It's used as caustic soda. It's also called a surfactant, which means a surface active agent that lowers the surface tension. Sodium hydroxide as feedstock for making soaps. We call the process saponification. Sodium hydroxide is also used in bleaches and also in the manufacturing of textiles. The uses of hydrogen gas, H2, that you can mention, in the manufacture of ammonia, NH3, in the manufacture of margarine, where you take H2, you add vegetable oil and you get margarine. Now, platinum is used as the catalyst, and the process is called hydrogenation. Hydrogen gas is also used in the manufacture of other compounds such as HCl, H2SO4, HNO3, etc. H2 is also used in the production of nylon material, and hydrogen gas is also used as spacecraft fuel. The impact of the chlor-alkali process on the environment. We can mention at least three. Carbon dioxide emissions from coal-driven electricity supply can cause the acidity levels of the nearby dams and rivers to rise, having adverse effects on aquatic life and drinking water. The second thing is waste management of brine muds that could contain other harmful chemicals should be strictly controlled. And thirdly, the management of the seals of the containers and vents and the transfer of all these chemicals should be strict to prevent toxic chlorine gas or corrosive caustic soda to escape. Please study well, use this video when you do revision, and always aim for 100%. Click the like button, subscribe and ring the notification bell. Goodbye for now.